Okay, let's get started with 5-43. So you should have the ebook open and be looking at lesson 5.14. What new connection can I make? And then 543 says, based on the tables below, what are the x and y intercepts of the corresponding graphs? Use the fact that the relationship shown in the table in part B is quadratic to write an equation to represent the relationship. Okay, so you might look at this and say, how am I going to figure out this equation? Well, you could go from a table to a graph. You don't have to go straight to an equation. So I'm going to graph these points. So starting with 3, 0. So I would recommend using a full sheet of graph paper. And remember, I always have graph paper. I don't always remember to tell you to take some home for the homework. So feel free to just come get some and have a little extra at home. You have the point 0, 16 and negative 5, 0. Okay, then we also have the point negative 1, negative 8, another 622. Oops, negative 1, negative 8. How could we have a point negative 1, negative 8? So actually, I'm realizing you can't write an equation for this. This is negative 1, negative 8. That's not going to give us a quadratic equation if we graph negative 1, negative 8. So I guess all of these are not going to have an equation. Let's just go ahead and move on to B. Let's see. For B, I'm not going to use graph paper because I'm looking at these points and I'm seeing that I've got, some really low points. I've got some really high points. I'm just going to make a rough sketch. So if you look at these points, you could use graph paper, you could use Desmos, or let's just do a rough sketch. So 7, negative 27, I'm kind of mapping this out in my, you could do like a little rough sketch on your paper. So 7, negative 27 is going to be in the fourth quadrant. 1, 0. Okay, it's hitting the x-axis at 1, 0. This is not my final graph. I'm just kind of mapping this out. 10 is negative 67.5, so way down here. And then I've got 0, negative 2.5, 2.50. Oh, wait, this is going to be 10, negative 67.5, and then negative 7 and negative 76. Okay, so this looks like it is going to be a parabola. So I'm going to do a little bit better sketch of this, but this helps me to visualize it. And I really don't need some of these points to write the equation. So I'm going to do a better sketch. So I have the point 1, 0. So there's an x-intercept. And then I've got the point 0, negative 2.5. There's my y-intercept. And it did tell us in the directions that this is a quadratic equation. So it's not linear, it's not exponential. Okay, and then we've got 2.50. So that's another x-intercept. Okay, and we really don't need these other points. I'm just going to focus on my x-intercepts and work on that equation. So it's going to look something like this, although I don't really know where that vertex is right now. I can figure that out. But I do know that if it is an x-intercept, then one of my factors must be x minus 1. Okay, and likewise, if 2.5 is an x-intercept, then 2.5 minus, or sorry, x minus 2.5 must also be a factor. Because think about it, if you plug in 1 here, 1 minus 1 is going to give you 0. If you plug in 2.5 right here, you're going to get 2.5 minus 2.5. You're going to get a y value of 0. So you've got your factors. Now, there is a possibility that you have more to this equation than just these two factors. And you should always account for that. You could just put a coefficient of a, and let's go ahead and multiply x minus 1 times x minus 2.5. So that's going to give me x squared minus x minus 2.5x and then positive 2.5. Okay, let's write this product as a sum, and we can combine these two terms that are alike, so that would give me, I'm going to bring this a down, which you might be wondering what that is. You'll see in a minute. Negative 1x and negative 2.5x, that's going to be negative 3.5x. And then plus 2.5. Now, if you multiplied these together and said that's the equation, you might be right, but we have several other points on this graph that were given. So I'm going to use the y-intercept just because it's easy to check and see if the equation is simply this or if there's more to it, if it's being multiplied by a common factor, or if that common factor has been factored out, it would look like this. So let's take this point 0, negative 2.5 and substitute the y coordinate for y. 0 is going to be my x coordinate. Oops, 3.5. Well, 0 times itself is 0, so this is 0. 3.5 times 0 is 0. So you wind up with just 2.5 in the parentheses times a equals negative 2.5. To solve for a, you're going to divide both sides by 2.5, and that's going to give you negative 1. So you may have looked at this and not remembered that you have to do something beyond just getting those two factors. If this is facing down, which we know it's facing down because of where the points are, then we know that the leading coefficient, remember this, ax squared plus bx plus c, if the a is greater than 0, it's going to be a happy face opening up. If a is less than 0, it's going to be a frowny face opening down. So if this is a frown, if this is opening down, then I know this leading coefficient has to be negative. And we just figured out what that coefficient is. Algebraically, we figured out that a is -1. So then I'm going to plug that in either here or here. So you could just write your final answer as y equals -1, and usually you don't write the 1, you just put a negative sign, times x minus 1 times x minus 2.5. If you wanted the equation to be in standard form instead of factored form, you could put a -1 right here, in which case you would get negative x squared plus 3.5x minus 2.5. So in standard form, you've got this equation, and then in factored form, you've got this equation. So let's go ahead and write that. Okay. Part C, I'm going to come back over here and sketch what this looks like. I've got the point 0, -16. And this is just a rough sketch. So 0, -16, -5, and 11, so way up here. I've got the point 3, -2, and 8, 0. And I'm looking at this and thinking, this is not going to be a parabola. We also have 13, 27, so kind of out here. And then we've got -6 and +14, so there's another point up here. So this is not a parabola, and I think all we need to do is identify the x and y intercepts. So 8, 0 is my x-intercept, and 0, -16 is my y-intercept. But I can't write an equation for this because just looking at it, you can tell there's no symmetry, and it's not a parabola. Okay, let's move on to 544. So it says to solve the equations and then to check your solutions. So I've got for part A, 6x minus 18 times 3x plus 2 equals 0. So zero product property says that if this quantity times this quantity equals 0, then one or more must be equal to one or more of these factors, maybe both of them, equal 0. So if this is equal to 0, I'm going to add 18 to both sides and then divide by 6. That's going to give me 3. If this is 0, I'm going to subtract 2 from both sides and divide by 3, and that's going to give me -2/3. To check my answer, I could just plug that in. If I plug in 3 in the place of x, I get 6 times 3, which is 18, minus 18, that gives me 0. To plug in -2/3 here, 3 times -2/3 is the same as 3 over 1 times -2 over 3. So that would be -6 over 3, which is -2. Lots of ways to think about this. You could just cancel those 3's out right there. So -2 plus 2 does give me 0. And another way to check this would be to graph it. If you graph it on Desmos. I'm going to show you on my graphing calculator. So when I graphed it, I noticed that it's hitting the x-axis. I'm going to press, and you can do this on the calculators that we have. It's just easier to see on the video with this calculator. If I press trace, and 3 should pop up right on 0. There's an x-intercept right there. And then I'm going to do negative 3 over 2. Oops, sorry, negative 2 over 3. And that is my other x-intercept. Okay, part B, we have so every time we do problems like this, someone always says, well, do I just add 10 to both sides? You can do that, or subtract 10 from both sides. You can do that. It's not going to get you anywhere, but you can try it. So hopefully you're starting to recognize these are not linear. You are not going to approach this the same way you would approach a linear equation. This is a quadratic. It's a parabola. And I already know what it's going to look like. It's going to be opening up. I could plug in points and find what that graph looks like. I could use my calculator to figure out what it looks like. Or I could go from the equation to the table by factoring. So I'm going to factor x squared minus 7x plus 10. That's going to be a 5x and a 2x, and both will be negative. So that's going to give me x minus 5 times x minus 2. You should be getting pretty quick at these. And to figure out the solutions are where this is equal to 0 or this is equal to 0. X minus 2 equals 0. If x minus 5 equals 0, then x equals 5. If x minus 2 equals 0, then x equals 2. So my solutions, which would be my x-intercepts, would be 5, 0, and 2, 0. And you could check this on Desmos. You could graph this equation right here. You could find the zeros just using a graph. This is just an algebraic way of doing it, and yes, you will have to do that on the test, so it's good practice. Okay, part C, we have 2x squared plus 2x minus 12 equals 0. So already they have replaced y with 0, and you are at the point where you just need to factor it. Hopefully you're going to recognize, although it's not too hard if you don't on this one, but all of these are divisible by 2. So let's go ahead and factor that out. So that gives me x squared plus x minus 6 equals 0, which is a little bit easier to factor than 2x squared plus 2x minus 12. That 2 that we divided by is a common factor. It doesn't just disappear. It is a factor of this quadratic. Okay, so let's quickly factor x squared plus x. That's going to be a negative 3x and a positive 2x. So that's going to factor into x minus 3 and x plus 2. So this 2, a lot of people will see this 2 on the outside of the parentheses and just automatically start distributing because you're used to doing that. But think about what the problem is asking you to do. It's not asking you to simplify, it's asking you to find the solution. So you've got 2 times x minus 3 times x plus 2 equals 0. And that means that x must be equal to 3, or x must be equal to negative 2. If these three quantities multiply give me 0, then I know that this must be equal to 0, or this is equal to 0, or they're both equal to 0. Okay, part D is a little different. Part D if you started by adding 1 to both sides, you would actually be on the right track. So yes, this is a quadratic. I could approach this 2 different ways. I could say, well, standard form, ax squared plus bx plus c, has an x term. And we learned that when that x term is missing, we put a 0 there. So I could say 4x squared plus 0x minus 1 equals 0. Factor that out. I'm going to do that. That's going to give me negative 4x squared on top, 0x on the bottom. So then I know this has got to be 0 times something. Wait, no. I know this has got to be factors of negative 4 that add up to 0. So I know that these are going to have to be opposites. So I know it's going to be 2x and negative 2x, because that multiplies to give me negative 4, but when I add it, I get 0. So that's going to give me 2x here, 2x here. This is going to be negative 1. This is going to be positive 1. So then this factors into 2x minus 1 times 2x plus 1. And now we can solve for x. So these are almost the same. By the way, okay, there's 3 ways we could approach this. I wasn't thinking about the third way right off the bat. Okay, so if I solve for x, I'm going to add 1 to both sides, divide by 2. So x is 1/2. And here I would subtract 1 from both sides, divide by 2. So x is negative 1/2. So that's one way of getting the solution. The other way would be to maybe you recognize, let me write this again, maybe you recognize that 4x squared minus 1 is a difference of 2 squares, or in Khan it just said difference of squares. If you see 2 perfect squares, which we have here, 4 is a perfect square, 1 is a perfect square, then hopefully you will start to recognize that's always going to factor into a plus b times a minus b. A is the square root of a squared, b is the square root of b squared. And isn't that what we got right here? We got 2x minus 1 times 2x plus 1. 2x is the square root of 4x squared, and then 1 is the square root of 1. The other way to do it, and I'm going to do this because it's coming up, I'm going to be doing this in a future lesson, would be to do plus 1 on both sides, because you can isolate at x if you do this. If it was something like 4x squared plus 2x minus 1, you wouldn't be isolating x if you just added that or got rid of that constant. You would still be stuck with an x squared term and an x left side, and that's not going to get you anywhere. But here, you don't have an x term, so if you do this, you wind up with x squared equals 1/4, and the opposite of squaring is taking the square root. So guess what? I've got x equals either positive or negative. Oops, and I wrote the answer before I should have. Square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4. Isn't that what we got up here? Positive 1/2 and negative 1/2. So 3 different ways to approach that. Hopefully this is starting to make sense. Let's see, we are on part E. X squared equals 9. So I'm looking for what number squared equals 9. So a lot of people will say, okay, that's 3. That's correct. The opposite of squaring is taking the square root. When I take the square root, I have to be careful here, because it's not just positive 3 times positive 3 that could give me a 9. Negative 3 times negative 3 also gives me 9. So my answer is plus or minus 3. Okay, and then we have x squared minus 2x plus 1 equals 0. I don't know if you recognize this one, but this is a perfect square trinomial. So that looks like this: a squared plus 2ab plus b squared. And actually in this case it's a minus. Now these are a little bit harder to pick up, but you did a con-assignment like this in like November or December. This is always going to factor into a minus b times a minus b. I recognized it because I said, okay, 1 is a perfect square, and then I just have done enough of these that I know that this is a perfect square trinomial. If you don't recognize it, you could just go ahead and factor it. Let's go ahead and do that. So that's 1x squared on top and then negative 2x on bottom. So these have to multiply to give me positive 1, add to give me negative 2. That's going to be negative 1x and negative 1x. So that's going to factor into x minus 1 times x minus 1. You can always do it the long way, but if you start to recognize perfect squares, you're going to recognize, oh, guess what? I know this is going to factor into the square root of this term, the x squared term, which is, let's see, I'm going to write this down here, x minus the square root of this term, which is the square root of 1, is 1, times x minus 1. Whichever way makes the most sense to you. Oh, and then we need to write the solution. So 1 is my solution, because if I plug in a 1 in here, I'm going to get 0 for an answer. Okay, what about part 545? What values of x will make the following equations true? So we have x squared equals 64. So think about what number times itself equals 64. And hopefully 8 popped into your head. 8 times 8 is 64. You're taking the square root of 64. And the square root of 64 could be a positive 8. Could also be a negative 8. So negative 8 times negative 8 gives you a positive 64, so x equals plus or minus 8. Okay, this is a preview of what's coming in a future lesson. So we'll be doing these on Khan and paper and pencil. So here we have x plus 1 squared is 64. Okay, well let's just do this algebraically. The opposite of squaring is taking the square root. And the square root of 64 we said is plus or minus 8, right? So we are undoing the squaring and we get x plus 1 equals plus or minus 8. That's two different equations. That's saying x plus 1 could be positive 8. X plus 1 could be negative 8. Well, if x plus 1 is positive 8, subtract 1 from each side, I get 7. If x plus 1 is negative 8, subtract 1 from each side, and I get negative 9. So my two solutions would be 7 and negative 9. If I plug in a 7, I get 7 plus 1, which is 8. Square root is 64. If I plug in negative 9, I get negative 8 plus 1, which is negative 8. Square negative 8, which is negative 8 times negative 8. Not, okay, this, remember this is different from this. This is negative 64. This is positive 64. Okay, part C says x plus 1 squared minus 64 equals 0. I'm going to solve for x by isolating it. I'm going to get rid of this. I'm going to add 64 to both sides. Well, guess what? Isn't this what we just did? X plus 1, whoops, x plus 1 squared equals 64. Didn't we just solve this over here? So they're taking you through this equation step by step. This is really what the equation looks like. You did the very first part, then you kind of did the middle part, now you're doing the whole thing, which I'm actually not going to repeat because we just did it. So let's just draw an arrow. This is part B. Could you do these graphically? Yes, you could. If you want to use Desmos or a graphing calculator, if you know how to use that technology to your advantage, it is going to benefit you quite a bit. Okay, let's do 546. To paint a house, Travis leans a ladder against a wall. So right there you should be thinking, okay, what is this going to look like? You've got a ladder leaning against a wall. You've seen this before. It's probably going to be a right triangle. If the ladder is 16 feet long and it makes contact with the house 14 feet above the ground, what angle does the ladder make with the ground? So let's draw this picture. Here's the ladder. Here's the house. Isn't this a right triangle? He leans the ladder against the wall. The ladder is 16 feet long. And it makes contact with the house 14 feet above the ground. So here to here, this is 14 feet. And we want to know the angle. We want to know the angle that the ladder makes with the ground. So this is going to be, let's go ahead and do our arc and our arrow. This is my opposite. Longest side is my hypotenuse. This is my adjacent, but I'm not looking for it. Don't need it. Not going to worry about it. This is going to be I have, and I have, and I need theta. I'm looking for the angle. I have my opposite. I have my hypotenuse. If you have learned how to use SOHCAHTOA, which you'll need it for PSAT, won't necessarily need it if you're in my room for a test because it will be there. Okay, opposite and hypotenuse. A quick way to remember this is SOHCAHTOA. So is S-O-H, Ka is C-A-H, and then TOA is T-O-A. So that means I'm going to use sine. O and H is sine. So sine, here, let's come over here. Sine of theta equals, sine is the opposite over the hypotenuse, so that's 14 over 16. That means I'm going to use inverse sine. So I go to my calculator or Desmos. Make sure if you're using Desmos that it's in degrees. And I do inverse sine, 14 over 16. Whoops. About 61 degrees. So theta is 61 degrees. Okay, let's look at 548. We have not spent much time on probability, so maybe just a homework problem here or there won't hurt. A sandwich shop delivers lunches by bicycle to nearby office buildings. Unfortunately, sometimes the delivery is made later than promised. A delay can occur either because food prep takes too long or because the bicycle rider gets lost. Last month, the food prep took longer than expected, or the rider got lost 11% of the time. During the same month, the food prep took longer than expected 18 times. The bike rider got lost 12 times. So they're telling us that these things, these conditions happened 11% of the time. In this sentence, the food prep took longer than expected, or the rider got lost this percentage of the time. And then in the next sentence, it's telling you food prep took longer than expected, exactly how many times. And the bike rider got lost exactly this many times. So there's 200 deliveries made during the month for a randomly selected delivery last month. What's the probability that both food prep took too long and the rider got lost? So I am going to do an area model to kind of visualize this. And I'm just realizing I skipped 547. I'll come back to it. this video is getting a little long. I might just stop after this one. I don't know, we'll see. Okay, so we're talking about food prep taking too long. We're talking about the rider getting lost, and those are the reasons that the food would be delivered late. So here food prep takes too long, here it's on time, and it tells me that the food prep took longer than expected 18 times in this month. So too long is 18 out of 200. And I didn't put it here because it didn't say that the food prep took too long and the rider got lost 18 times. It just said that the food prep took too long 18 times. And then it says separately the bike rider got lost 12 times. So then bike rider gets lost, not necessarily the food taking too long. The food's on time. The rider gets lost 12 times out of 200. Here he doesn't get lost, not lost. So I also know that in that same month, the food prep took longer than expected, or the rider got lost 11% of the time. So I know that these outcomes happened 11% of the time, but that sometimes the food prep was too long and the rider got lost. Here, if it's on food prep's on time, rider doesn't get lost, everybody's happy, the food gets delivered on time. Sometimes the rider is lost and the food prep was too long, but I don't know that the number of occurrences there. So I know that 18 over 200 plus 12 over 200 minus the times when this happened. I don't know if these overlap. I don't know. I'm sure there's some overlap where the food prep took too long and the rider got lost, but I have no idea how much that is. So minus X out of 200 equals 11%. Now I could write that as 11 over 100. And because all of my fractions have a denominator of 200, I'm just going to make this a denominator of 200. So that'd be 22 over 200. Okay, so that's going to be 30 over 200 minus something equals 22 over 200. Well, that must be 30 minus 8 would give me 22. So X must be, well, that's going to be a little confusing because it's going to ask you for the percentage. Let's see, let's do 30 over 200. So 0.15 minus X, how many out of 200 equals 0.11, 11%. So that's going to be, I kind of like to just move this over to the other side. So 0.15 equals 0.11 plus X, and then subtract whatever's on the same side as X. So that's going to be 0.04, so that would be 4% of the time. Okay, I think we can quickly do 47. Let's just sketch it really quickly. It wouldn't hurt to review. 547, you have a large triangle and a small triangle, and they are overlapping. This is an isosceles triangle, and it's asking us to find these angles. So remember, in an isosceles triangle, base angles are congruent. So I'm going to say 28 plus, I know these are going to be the same, plus x equals 180. All the angles in a triangle sum to 180. So that's going to give me 28 plus 2x equals 180. We'll solve for x, subtract 28 from both sides. Let's see, 160, 152, and then divide by 2. Okay, so x is 76. And if I extend this line, this is a full circle. This is half a circle. Full circle is 360, half a circle is 180. So these two together have to add up to 180. So let's see, this one is 76 over here. 180 minus 76 would be 104. And then looking at y, these two, there were matching arrows here. These two lines are parallel, cut by a transversal, so these 4 angles match these 4 angles. So if I were to trace this and slide it down, it would be equal to this angle. So y equals 76 also.